Ready to go, that's for sure. Good morning, everybody. Good morning, everyone. Good morning. Great. When I was asked by Jill a few weeks ago if I wanted to come here and give a talk, I naturally said yes. Then, of course, I went through the whole process of, well, who's the audience? And realized that the audience out there probably has a lot more actually experience at using the cloud than I have. And perhaps I should be part of the audience rather than giving the talk. But it's always hard, I think, to think about something different, particularly when you talk about cloud computing, because it's something that has headlines almost every single day of the week. So it's very difficult to perhaps do something different. So that's what we're going to try and do today, is do something different, different perspective perhaps, hopefully give some education, some thoughts and ideas for those of you that are not using the cloud as to how to get there. But every time I give a talk, nevertheless, I'm always reminded of one of the last centuries. I must admit, it was a day in my life I never thought I'd talk about the last century. One of the great statesmen, Winston Churchill, he would say the three hardest things in life to do are, number one, scale a wall that's leaning towards you, kiss a girl that's leaning away from you, and then number three was giving a talk. So we're doing the number three this morning. So we're going to deal with that. So let's take a look-see first of all. Cloud computing. Boy, it makes my brain hurt, that's for sure. It's got a language of its own. It's got an alphabet soup. It's ever increasing. It morphs over time. And people keep asking, what is cloud computing? I think the answer is it's whatever you want it to be. So you think about that, and you think about, well, how do you get started? How do I use this? Or what's the best way? And every day in the press, with this online media from various publications and various vendors, there's about 3 ways to do disaster recovery in the cloud. 7 tips on how to morph to the cloud. 7 of this, 10 of that, top 10, top 5. There's a ton of information out there, and it's growing. This panel before talked about things like big data. And big data is very much in there. But for the high-performance computing world, of course, some of these techniques aren't new. They've been around for a number of years. I've been in the HPC marketplace, I hate to say, over 30 years now. And it's a marketplace that once you're in, whether as a user or as a vendor, I was more on the vendor side, once you get that HPC drug, it's in there for life. You can never get rid of it. So you've got to think about those things. So I thought, how do you do things differently? So I thought about, okay, let's talk about the agenda. What are we going to try and cover over the next 25 minutes now? How did we get here today? Quick reminder of perhaps what cloud computing really is, but really drill down to perhaps a few of the differences, public, private. But first of all, who in the audience here is actually using the cloud today? Let's see a show of hands. None. I can't believe that. Who's got an iPhone?
Well, experimenting, using for HPC.
Yeah, that's true. But I mean, it's it's a good point. But it's there. ROI, return on investment. Can you really make a business case for cloud computing? I looked at this and I realized that when I did my presentation, finished it over the weekend, I go back and do the overview, and CC is cloud computing. So we get 7 things here. But actually what I was doing, I was drinking Canadian Club and 7-Up at the time. So I think that's really how this agenda came about. All right. So imagine this scenario. You sit down at a keyboard, your device, you sign in, name, password, usual stuff, load the application, load the data, execute, wonderful, sign out. And then at the end, you get notification, your results are all there, and you get a bill. Bill for CPU time, storage time, memory time, whatever it may happen to be. And all through this whole process, you think, wow, this is really, really simple to use. How difficult can this be? At the same time, I haven't spent any money on infrastructure, haven't bought any storage, bought no CPUs, bought nothing. But when you think about this, what really is this? Let's take a walk down memory lane. When I first got in the computer business a lot of years ago, I did this kind of thing. This was my input device. Some of you here may not even recognize what this actually is. But this was my input. This was my keyboard. I signed in through the keyboard here. This was my data or my application in some cases. If I was lucky, this is like 1971 time frame. If I was lucky, I got access to this wonderful device, a card punch machine. You get your program to your Fortran 4 or whatever it was back then, or your IBM Cal code at the time. And the great thing about paper tape and punch cards, you got good enough that you actually could put it up in the light and actually read what was actually on there. Or you could splice it and change it. So it's really, really flexible. And the data center looked like this. Big, humongous, monolithic computers, tape drives, all the rest of the stuff. But here I was basically still doing the whole process of time sharing, which was really Not that different from today's cloud computing. It was access to powerful computing resources, pay as you go. Pay for memory, pay for storage. You didn't think about it. And here's an example of an ad, GE. I was surprised when I found this. GE, here are selling computers, selling time sharing. But when you go back in those days, you got companies like Univac, Burroughs, NCR, all with time sharing offerings. Now, of course, when you come back today, very few of those companies actually exist. Obviously, IBM, Hitachi are two examples that do still exist. That's what it looked like back then. Sign on, load the application, load the data, execute, sign off, pick up a bill, pick up results. Very nice. So it's very much cloud computing, truly is back to the future. But over those time frames, basically, when I think about my experience, I think about what are the evolution of the data center that's happened over that same sort of 30-plus year time frame and how it got to where we are today. So we start out with a big monolithic mainframe. It moved to distributed computing kind of in the 80s. The Unix-based, the sons of the world, changed computing, distributed model. Then it changed from distributed to very much a three-tier architecture. And the three-tier architecture came about with the web and how it changed life. And it morphed to a grid architecture and grid of grids. And then it's morphing very much to the cloud architecture, what I call fifth generation. But as it's gone along each of those shifts in architecture, there are certain things that have been important in those areas. And I'm not sure the folks at the back there can really read this, but basically there are certain things. The mainframe world, it was about centralized, it was about proprietary, it was about security, really good security, mission critical applications. But also it was about virtualization. Who thinks virtualization was invented 10 years ago at VMware? Nobody, that's good. Virtualization came about around about the 69, 70 time frame at our labs of IBM and also Hitachi. Hitachi called it MLPF, multiple logical partitioning function, I think MLPF was. But they were hardware-based virtualization. Split that piece of hardware, that huge system into chunks, do time sharing. It's the only way you can actually afford the leasing of these systems. They're very, very expensive. But those kinds of things follow through the years. Workflow management. Then you go to distributed architecture, very much the era of the Ethernet. Ethernet everywhere, open systems, standards-based. Then a network, web-based, basically the concept that any device, anywhere, anytime access information. Very much internet-based. I think what's made cloud computing very much possible today, of course, is the commodity processors and the ubiquity of the internet access from any device. And the grids, of course, modular, inexpensive, and today's dynamic and efficient cloud computing environment. So it's evolved over decades. Cloud computing, I think, didn't just arrive 5, 6, 7 years ago. It just didn't arrive 10 years ago. I think the essence were really back in the mainframe days. So I'm showing my age here, by the way. Cloud's potential, what's all the fuss about? And given that, what's the fuss? Well, it really is, I think, pay as you go. Pay for the drink, like utilities. Pay for what you use. Rapid deployment. I think one of the comments in the last session was about how do you get into the cloud, where should you start? There's lots of different ways to do this, but one method I think suggested was basically do development, do rapid prototyping, find out what it's like, try it, see what it's like. And you can do that very much in the public cloud, but the public cloud may not be where you ultimately deploy the final solution. But you can actually get into it, you can try it out, very expensive from various providers out there. And it's very much self-service. Do what you want, when you want to do it, how you want to do it. Characteristics are important. Really is, and advantages, really important. You know, when you look at the data center and you look at where most data center environments have pooled resources. They're virtualized, very important. Virtualization is also an enabler, I think, for the cloud's environment. And some people would say, without virtualization, you can't do cloud computing. You know, whether it's true or not, I'm not sure. I think it is, and I believe it is. But you pool your servers, you pool your storage and network applications. But the advantages are huge. But there are no two the cloud environments the same. Some people will achieve efficiency, some flexibility, some will achieve that. Some will achieve security, automation, workload management. The aspect down here about green computing and green tech is very, very, very big. And you know, many data centers around the world, the biggest single line item is the expense to drive electricity, actually drive the servers and the storage and all those resources and the air conditioning. So if you can go through some of these processes and do virtualization, do consolidation, all of a sudden you can actually physically shrink the amount of square footage in a data center, and that has an impact upon less electricity, less space, and you start achieving really great savings from a green point of view. It's also very socially responsible for many organizations as well, which I think is a good thing. Considerations, private and public, they are different, no question. Private's about customization, complete control on your resources. However, it can also be a distraction from what you're trying to do, from your basic business, and how you're doing science and research. Public cloud, on the other hand, is cost effective, no question, and there's no investment. You don't have to buy servers, you don't have to buy storage, you buy what you use. So there's huge financial savings, perhaps more so on the public side than on the private side. However, public computing, you don't have any control. Security concerns, wow, that's a really, really big deal out there in the marketplace. And there's certain risks there. However, you can certainly rapidly prototype in a public cloud environment, test it, try it, see it, and then deploy in a private cloud environment. And that brings up the topic of hybrid, which is somewhere between the two. A lot of organizations take the mission-critical, really important applications where the data is really sensitive and really important, and run that in a private cloud environment, but do all of the applications on the private cloud. So you get the hybrid environment, a mixed environment. Things like document management, etc., and email perhaps, so they are secure and they are important. They might be better off on the public cloud than on the private cloud environment. Private cloud, I think, borrows techniques much like the data center evolution of where it started, I think, in mainframe days and time sharing to where we are today. There's certain aspects that the private cloud draws from both public and from virtualized data centers. The trust and control, dynamic, efficient, flexible, on-demand, agility. And you hear all the vendors talk about agility and flexibility and cost effectiveness. And that's all very, very true, certainly. And, so it's really, really there. So private cloud basically has the benefits from both a virtualized data center and benefits from a public cloud brought together in a single environment. All in your total control, absolutely under your own control. Some of the drivers, transaction pace, there's no question, anytime, anywhere, it's there, it's happening. The evolution of products like the iPhone, the iPad, kind of talking like an Apple commercial here. But they're changing the way we're accessing data, no question about it. The sort of scientific notebook can be an iPad, running your applications, getting results as a user, or as an IT manager, looking at your resources, or iPad for an iPhone or Android or whatever. You can access these resources now from any device, anywhere, pretty much anywhere in the world. Agility, rapid innovation, most definitely there, and a focus on core competency. Core competency is about the science, about the business you're in. What are you trying to accomplish? You want to really focus on that. Not have to worry about what the IT looks like and what kind of servers I've got, how many cores I've got, and how fast it is, how many gigabytes I'm using. That shouldn't be what you're thinking about when you're using these kinds of technologies and transferring those areas. So it's really important. Now, some of the things, standards-based, I think it's certainly growing. I think some of the lackings here that are still inhibiting cloud adoption is a lack of standards. There really are no standards yet, and standards seem to drive certainly some industry adoption of certain technologies. So they're going to come. Yesterday I was going through the usual 7 tips, 5 tips, 10 tips, etc. And then there was something about storage standards for the cloud. So they're going to happen. They're going to happen over time, but they're still very rudimentary, very crude. Third-party software, how it's licensed, are also things that have to change for this industry as well. Where does it fit? Where's my application fit? It's a fairly common slide. I'm sure some of you have seen this in many places before. At co-location down the left-hand side of the slide, it's expensive. From a point of view, it's CapEx. CapEx is basic capital expenditure. Far right-hand side is about OpEx. So you're spending operating expenses, actually drive and access those resources. Big data and storage, talked about in the last session too. It's very important. I think a lot of big data and big storage probably depends on how critical that data is, how secure you want that data to be. That's the way you might actually have that in the cloud environment. And again, you might have it in a mixed environment, mixed places. So it's really important to look at it, look at your application, understand the workflow, and what makes the most sense for you and for your organization to actually deploy cloud computing. There's also discussion last session about graphics and animation. And I think about some of the organizations in Hollywood that do the special effects, post-processing of movies, the special effects. Huge amounts of data. Most of the data is processed very much in a private cloud environment. The reason for that is that data is critical. We're looking at the next generation Batman movie. These are worth billions of dollars to Hollywood studios. Incredible security. So you obviously tend not to have that out in a public cloud environment. So the environment, the industry kind of dictates to a great extent what it is you're trying to do and where you put your applications and your data. Benefits of cloud. Benefits, there's cost of infrastructure benefits, there's business benefits, and there's IT performance and agility benefits. The costs are certainly areas that mean most to most people, in the sense that you can actually understand it. If I can go from 100 servers down to 50 servers, for example, there's clearly a cost savings there. If I can go from 10,000 down to 3,000, 5,000, do the work. And virtualization, to the great extent, actually helps with this, because what virtualization does, it takes that server, and it takes that utilization rate, and if you believe what the industry talks about, they talk about typical utilization being 15 to 20%. Bring in virtualization, you can raise that 20%, for example, to 60 or 70 or 80% utilization. That's like getting a 3 to 4x performance improvement on the same old piece of hardware that you had maybe for a couple of years. But our cost savings on servers, on storage, energy, and these are real serious big dollars. Access to the system from a business point of view, and agility, innovation, rapid prototyping, try things, scale up, scale down your application. Pay for what you want. And the IT performance, it's a service industry. All of a sudden we're talking about an industry that's a service, it's no longer a product, it's a service. And I think about changes in business these days around the world, it's about two things which are really important, sustainability and service. You've almost got an industry that's sustainability as a service, is kind of what I talk about when it comes to cloud computing, because you have benefits from both those areas. Really a great model to actually look at and use. Silver lining to many people, to go back to the cost side of a current environment, to go to a private cloud environment, can you really see a 45% decrease in your actual costs? Your actual cost of hardware, software, staff. 45%, is that average? Maybe, maybe not. Again, no two data center environments are the same, but you have the opportunity to actually really see real savings. To a lot of people, this is what becomes a driving factor, whether I go to the private cloud or keep doing business as usual. And in private organizations, companies and public companies, very much decisions are made, of course, from a cost-benefit point of view. In some academia, HPC environments, it's maybe not quite as black and white, though I think it's certainly changing, because budgets are less than they were before, and it's a classic case of do more for less, or do more with less. But there are more savings that can be obtained even in this environment. There are, depending on where you live, where your data center is, the state, the city, etc., there are a lot of other things you can actually do. You can do trade in your hardware, upgrade your hardware, do lease back, lease refresh, and work with utility companies. And a lot of utility companies, particularly in California, have rebates. They have the ability to actually rebate, because electricity is increasing in price, decreasing in availability, and decreasing actually in reliability of service. And so with data center rebates and with refresh technology, leases, etc., you can actually almost pay for a brand new data center, like servers, hardware, networking, with the money you're going to save through these kinds of processes. So there are techniques and there are places to go to look to see, how can I get a rebate? How does it work? They're there. They're a fairly complex process to go through, as you can well imagine, with the utility company, but it's worth looking into. So you're looking to transition to cloud computing, look at the utility company, look at your local providers, because the cost of electricity is only getting higher. The cost of a barrel of crude oil, I think, is $125, $121.25 a day. That cost is going to go up, no question about that. I don't see oil coming down to $50 a barrel anytime soon. There are challenges, however. These challenges are really, really important. And again, you can go look at a variety of industry reports, and they obviously poll their users about challenges. And typically, data security and confidentiality is typically in the top 3. So people still view this as a challenge, and it's also viewed very much as a challenge to the adoption of cloud computing. It's a big fear out there, no question about that. I actually believe that things like cloud-wide system management is also a really, really big challenge. There's heterogeneous devices out there, different vendors' hardware, different storage architectures, different virtualization. Some data centers, you've got VMware. You've also got Zen and other forms of virtualization, all in the same environment. Performance is unpredictable. You're not really quite sure how fast it's going to run. You're out there in the public cloud, for example, or your own private cloud, sharing that resource with a bunch of other people. So you're not quite sure what the performance is going to be. So it is a challenge, no question about that. To drill down a little bit on the security, Last year, 2011, was a really, really bad year for public notification of cloud and internet breaches and security. You know, RSA, one of the leading data security companies, Lockheed Martin, Epsilon, NASA, even companies like Sony and PlayStation. I mean, these are huge, big breakthroughs. FBI. These were all headlines during the last 2011. Here we are, 2012. We're only into April. Think about that. And we've had several high visibility breaches and security of both internet and cloud computing. So it's a really, really big deal. No question about that. So when you're looking to go to the cloud, I really believe you've got to think about security as one of the really, really fundamental things. Whether it's private is a little better, because to some extent you're inside your firewall and you've got better control on its resources. However, the single largest breach in security is people who currently work for an organization that actually hack in their own systems. So you really, really got to think about security before you go to either private cloud or public cloud. Because again, it's not for everybody. Is this the future? Guy in the background, yo dude, back here. Cybersecurity. That's what the future is going to look like. You can read about it in the press almost every single day. It's it's a big, big target. Terrorism, etc. It's out there, no question about it. And you've got to guard yourself against that as best you can. And it's a moving target. You've got to continue to look at your best practice, look at security, and move on from there. Management tools, another big innovator. Problem with management tools, they're not well joined. There's lots of them. There's tons of choice. It should be ad hoc, I think, down the bottom of this slide. But there's so many choices out there. And the problem is, when you have a heterogeneous environment, because I don't actually know many, and even if you had a homogeneous environment of all the hardware, all the storage, all the networking from the same company, if in fact that's even possible and practical, management of just those resources is a nightmare of itself, because they're developed by different organizations in the same company, and they don't talk to each other. We saw this when I worked at Sun. We had the software groups, management group, and they didn't really spend any time talking to each other about, oh, how can we make it look like a seamless, single integrated environment? It never happened. It's disjointed. So as you move along that power curve, and you're looking for, the next level up the rung, of course, and we're getting here, I think, with the orange bit. They're well joined together. There's not many companies with that, and it's still a bit of a nightmare. What the world's looking at is we come right back ahead of what this event's all about, basically. You want tools which are well joined together. Boy, can you imagine if you had a single pane of glass, and a single pane of glass had access to and could look at all the virtual resources, all the hardware, all the software, all the storage, all the networking from a single pane of glass. It would be wonderful. Ease of use, ease of management. That alone would drive costs right the way down. So it's a very important thing. I think when I look at the adaptive computing and their resources, they're moving towards it. They're no doubt moving towards the right-hand side of this slide. No question about that. So, embrace the paradigm shift. It's here. It's not going away. Public clouds, great for email, great for document management. Private clouds, scientific research, human genome, computational fluid dynamics. All these things are gobs and gobs of data and very proprietary data. So in those kinds of environments, certainly security and certainly private clouds are probably a much better solution for you. Motivation, don't need to go through this. I've already talked about this really, but it really is reduction in costs, rapid deployment, scalability, flexibility. And it's a service, so better support, better services will come along with that. Essential guidance, wow. I really meant to have this slide have 6 bullets on it, but as you talk about it and go through it, you realize I've got to have this, you've got to do this, you've got to do this. But I think the essential guidance, I think, really is understand your application, understand your hardware requirements, understand your software requirements, understand your networking requirements as best you can, and look at the cloud or whether it's got real mission-critical applications, real mission-critical data. I don't want that in the public cloud, therefore look at deploying the private cloud. When you look at your own internal organization that comes to deploying a private cloud internally, it's going to be about costs. It's going to be about efficiencies. It's about driving those costs down. From a public cloud point of view, yeah, I think rapid deployment, rapid testing rather is a really good use of public cloud. Get a sample application, load it in there, try it out, see does it lend itself to that kind of environment, and use that as a test bed for private cloud. Don't agonize over it. Don't make your brain hurt. Get help if you're not sure what to do. I'm not sure we got time for questions, probably not.